Hey everybody, welcome to VC Talk. Today I'm here with Rob DeMillo. He is the CEO and founder of Sophia Space. As you may know, the majority of computing nowadays is done on Earth, but these may change fast because there are some companies that are planning to build orbital data centers, so data center in space. And today I'm here with the founder of one of these companies that may change and revolutionize how we do computing as human beings beside Earth and expanding in space and the universe. So thanks a lot for taking the time to have this chat with me, Rob. Please quick introduce yourself and then we can get started.
Thanks for the time, Giordano. My name is Rob DeMillo, and as I was just introduced, I'm the CEO and co-founder of Sophia Space. I started my career in the 80s at Jet Propulsion Laboratories back here in the States, and then moved from there to the FAA, and then spent 30 years doing entrepreneurial work. I
Yeah.
was approached early on by Leon Alcali of Mandala Space Ventures, and we talked about Sophia for about half a year, and we started it up.
Yeah, that sounds great. So more on your background. So you mentioned that you were involved in data center on Earth, right? Before in
Yes,
your previous life.
correct.
Yeah, and how many data center have you built on Earth? Or yeah, what was the path there and how you enter in this industry?
Right. So I didn't actually build data centers here terrestrially, but I was in and around them for the last 15 to 20 years of my career. So doing a lot of cloud computing work. I sold a company in 2018 that basically moved an animation platform into a cloud computing environment. And I spent a certain number of years at architecture firms that were looking at data centers, and we used them ourselves. So it's an extensive career that involves data centers and cloud computing.
Got it. Okay, that's super cool. And so, what is your thesis, or what is your idea? Why do you think that computing on Earth is broken and we need to
Okay.
move outside from Earth? What
Yeah.
is your thoughts
Well,
on that?
the demand for both data storage and data compute isn't going anywhere. It's growing fairly exponentially. I saw a great chart the other day that showed the number of large scale architectural work being done on office buildings versus the large scale architectural work being done on data centers, and those lines crossed this year. So
Yeah,
there are more data centers now being constructed than there are office buildings.
that's crazy.
Yeah, it is a little nuts. And so so we're overpopulated with data centers. The demand there is never going to go away. And I think at this point, everybody knows the problem, right? There's really nowhere to put them. They
Mhm.
consume a lot of electricity. They consume a lot of water.
Yeah,
They affect everybody's power grid. They affect everybody's economics in the area that they're living in. They
yeah,
produce a lot of heat, right? So, so it's an existential problem, more or
yeah.
less, as we move forward.
Yeah, and if nothing changes, so let's suppose that ODCs will never happen. What do you think will be like the global computing situation in the next 5 to 10 years?
Without ODCs, dire.
Yeah,
I think it's going to be what typically, unfortunately, tends to happen in situations like this, where uh, uh, parts of the world that are unable to uh, basically parts of the world will be taken advantage of. There'll be places, both countries and states within the United States, where data centers are placed over the objections of their populations, or maybe even the populations may not even be aware it's happening,
yeah,
because the consumption of compute is not going to die down. It's going to increase,
yeah,
not just through the AI and Instagram photos,
yeah.
but because it's the direction that computing takes.
Yeah. So, I mean, if ODCs will not happen, basically AI will not evolve or all
No,
these
it'll
networks.
evolve, but data centers will simply grow to take up land spaces that they probably shouldn't take up. And it's a little bit of a dire warning, but at the same point in time, companies are working hard to make high intensity compute processing with using less resources.
Yeah,
But still, as the demand grows, even if the holy grail of cool computing happens, right, there's
Yeah,
still an expansion problem. And
got it.
and what you're going to see happen is what I said, right? There's just impoverished areas are going to wind up being data center hubs.
Yeah. And why do you think that this wasn't possible like 5 or 10 years ago? Like, and why
Launch
do you?
costs.
Okay,
You mean
yeah,
getting to space? Yeah, launch costs really primarily. I always liken this to in the American Old West. It was difficult to go from, New York to Chicago
yeah,
back when there were just horse trails and goat paths. But once railroads came around, it became easier to move between those cities.
yeah,
And similarly, the same thing is happening going into low Earth orbit. It was not that long ago. It was about 6 or 7 years ago where it was $55,000 a kilogram to get to orbit.
right.
And now that number is somewhere around $2,700.
Yeah. So so the biggest bottleneck is like bringing stuff in space that now is getting solved.
Yep.
Do you think there's also like an issue in terms of heating dissipation? I know you guys have a
hmm
proprietary and
Yeah.
specific heating. Do you want to touch a little bit on that?
Yeah.
Like,
Yeah. So it's ironic because space is cold,
yeah,
right?
that's
The,
true.
the universe is a very cold place. In orbit, the ambient temperature is around 4 degrees Kelvin, which is extremely cold. However, if you think of the way a thermos functions, when you've got a hot thing that has no transmissible method other than radiation, heat radiation to dissipate its heat. Heat stays trapped in that object far longer. And
Yeah.
so if you've got a computer in orbit which is constantly generating heat, and that heat has nowhere to go except just emissive radiation, it's a problem, and machines do shut down.
Hmm.
And otherwise they use like heat pumps to get the heat out from computers. What we've done at Sophia is a little different. We worked with the physics of the situation of where we are in orbit. We've created a geometry for our servers that we call tiles
Yeah.
that allows heat emissions to happen naturally. So we
Yeah.
have a passive cooling methodology that works quite well.
Got it. And like personally, like your choice. So you saw this trend of okay, there's like a bottleneck, and we need more computing capabilities. Now
Mhm.
we can go in space and do potentially ODCs. What moved you like personally, like to say I want to build a ODC, like I want to build this type of company.
Yeah,
Um,
personally, it's interesting for me because I started my career in aerospace. All right, I was image processing specialist on Galileo spacecraft and a few other spacecraft, and I did that for the first part of my career,
yeah,
and then moved into entrepreneurial work, which led me into cloud computing and data centers. And then this opportunity arose
yeah.
to kind of tie the knot and complete that circle of my life, right? So my love of space and space technology and my love of cloud computing kind of all come together in a
So it was
nice
like
little bow here. Yeah.
so it was like a decision you made, and you said, you know what, I'm gonna build
Yeah.
this company.
Yeah,
Okay.
yeah, yeah, yeah. And, when the idea was like crossed my path, I toyed with the idea of like, you know what, I'll just go into retirement and that will be the end of that. And then I
Yeah.
started thinking about it. I'm like, no, I would kick myself
Yeah.
if I didn't do
I would
this.
regret maybe. Yeah.
Yes, yeah.
That sounds great. And so in terms of like the hardest technical or strategic component you face in the first year in the initial path, what would you say is the
At
important?
Sophia,
Yeah, Sophia.
at Sophia, we were blessed by fantastic engineers on our team that come out of Jet Propulsion Laboratory and
Hmm.
the aerospace community in general, as well as engineers we have from my cloud computing past on board.
Yeah.
And so we have an amazing engineering team. But
Hmm.
in making those things mate, it we spent a few months like teaching each other's terms. So getting those two worlds talking is always the first challenge. But the technology behind our passive cooling it comes from a study that was done at Leon's startup accelerator, Mandala Space Ventures, and Caltech and Jet Propulsion years
Yeah.
before. So we got the lineage of a lot of that IP, but
Hmm.
making it into reality. that wound up being an interesting challenge. And in addition to that, we built an operating system
Yeah.
that sits on top of these servers that assists in the IT control of the servers themselves. So the operating system helps with heat management and process distribution and a number of other things. So it really was a coming together of hardware and software
Hmm.
that is making this all work. And I'm very proud of what the team has done.
Awesome. That sounds great. And so many people think it's still like a moonshot vision, like building ODCs. Like to the risk this path, what is the category of customers you guys are targeting initially, like to make revenue as soon as possible?
Yeah, so we are selling our servers directly as edge computing devices to our customers over the
Yeah.
next several years before we get to the orbital data center side. And we're doing that for a number of reasons. One is it is a requirement now. All right, people have these amazing satellites in orbit that are capable of incredible sensor resolution and data collection, but they don't have the compute facilities to be able to handle it very well.
Hmm.
So by selling efficient orbital compute servers as edge computing devices, we've solved a very real problem, a very real bottleneck. So the first few years of our existence is that. And
Got
we're
it.
selling not only to government agencies, but also commercial agencies that are looking to do interesting things in orbit that they weren't able to do on the ground. And then in the 2030s, early 2030s is when we start putting up the orbital data centers in earnest, and those will function as data centers.
Yeah. Okay. That is very. I think it is a great strategy to get initial traction and like in terms of so competition wise there are I mean there's also StarCloud that
Mhm.
is biggest I mean the most well known
Yeah.
company in ODCs and
Yep.
other companies that are trying to come up also Elon Musk recently like
Mhm.
did a merger of SpaceX and XAI and
Yeah, of course.
he mentioned he want to go in the moon and build orbital data center. How do you see the environment evolving and competition wise? Do you see multiple players winning or like one like maybe Elon Musk now winning over everybody else? What do you see like the evolution of
Well,
the
well,
ecosystem?
first of all, the space, no pun intended, is big enough.
Yeah,
There's no shortage of data processing required or compute required in orbit, and so we welcome all players. And by the way, the larger players showing up, Bezos the other day, Google, Musk, it helps inform our story,
yeah,
right?
hmm,
Right, and I'm convinced that Sophia's technology, is the better mousetrap.
yeah,
And a lot of these folks will wind up being our clients, which is, be wonderful.
yeah,
But I welcome all players. Everyone is doing a different strategy
hmm,
for dealing with cooling and getting these things into orbit. And again, the market is huge, and
got it.
so
So,
all players are welcome.
so you believe there are going to be multiple winners basically?
I think so. Yeah.
Yeah, yeah, yeah,
Yeah, yeah. I mean, if you look at terrestrial data centers on the ground, there's not just
yeah,
Amazon,
yeah,
right?
yeah,
There's
100%.
Google, there's Microsoft, there's
Yeah,
Oracle, then there's dozens or hundreds of data centers planet-wide. So
yeah, and yeah. So and your unique approach, like yeah, maybe you already mentioned related to the heating component, but any other unique approach you have compared to anybody else?
the operating system. So because of the way that these servers are designed, they're very small.
Hmm.
They're meter by meter in size, in area, and they connect together modularly. All right, and so to have more computing, you just have more of our servers, which we call tiles,
Yeah,
and the operating system that sits on top of those tiles interacts all those tiles together,
yeah,
so that they operate as a single networked computer, which is part of the strategy moving forward.
got it. That sounds great. And so you recently raised and finalized the seed round of
Mhm.
10 million. Congrats on that.
Thank you very much.
Um, and like moving forward, which are the next key milestones for this year and next year?
We've got a lot.
Yeah, I
So
can imagine. I can imagine.
our servers are composed of four quadrants that we call blades. And we are getting back from our fab facility in the next few months the basically the first edition of those blades. And we'll wind up with 8 of them, which will allow us to produce 2 demo tiles. Those
Hmm.
tiles will go into environmental test chambers to make sure that the physical reality of the tile matches the mathematical model that we currently have. We've already done this test on a small scale with
Yeah,
a breadboarded version. So we know that it works, but we want to make sure that the full-blown version works. And we're also doing a ambitious software test later this summer, early this fall that I cannot publicly speak about,
sure. Yeah,
but
yeah.
there'll be a lot of press around it.
Got it. Got it. That sounds great. So like time to space, like for next year,
Second half of 27 is what we're targeting.
second half of 27. Got it. Got it. Got it.
Mhm.
That's super cool. And like a contrarian thought, like what do you think most people get wrong about space computing?
Um, a lot. Well, everyone
They go
focuses on
they
the
don't get it at all.
they don't get a lot of people don't get it. They focus a lot on the heat dissipation, which they should, by the way, because it is an interesting engineering and physics problem.
Hmm.
But a lot of it gets treated in the press as this is not solvable, or this is only solvable with giant coolers and big giant solutions, or millions of satellites in orbit to break up the processing into smaller, more manageable heat distribution problems.
Yeah.
Right, there's other solutions, right? And I think ours is unique and scalable,
Yeah.
and will result in some amazing compute power in orbit. But I think that's probably the first problem that people have, right? And then the second has to do with basically clutter in orbit, right?
Yeah.
And I don't want to play that or downplay that because it is a problem. But I can tell you firsthand that there are companies working on cleaning a lot of that up, right? And like all self-made engineering problems, there are solutions to that as well. So
Got it. Awesome. So I think that's all for this episode. It's a quick one, but again, I'm super excited about the sector. I'm super excited about the future of computing in space, and in particular about Sophia. I believe is providing and proposing a great solution in the market. So I'm excited to see where you're going to be in 1, 2 years.
thank you, Giordano. It's going to be an
Uh,
exciting couple of years. So I
yeah.
appreciate the time.
Yeah, let's see. Awesome. Thanks a lot for taking part to the podcast and catch you up. Have a good one. Cheers.
Take care of yourself. Bye bye.
Bye.